Now, you've seen the Dyson 360i in action, but now we're here in Toronto, Ontario at Dyson Canada's headquarters to learn about the tech inside. And joining me is Mike Aldred. He's the lead robotics engineer at Dyson. Thanks for joining us.
No problem.
So we had to kind of get a deep dive to see the technology, and you're the guy who basically worked on this. How long did it take to put this together?
Well, it's 18 years of my life I've put into this. So 18 years ago, James decided he wanted to develop a robot vacuum cleaner. So he brought us up from a university team and put us into Dyson and set us going.
Okay, so this here that we are looking at is a prototype of the first version of it?
Yeah, so after about 3 years, we'd got to the stage where we felt we had a first product and we wanted the world to see what we were working on. Although it was a fantastic product, it worked, it was methodical and had incredible cleaning power with Dyson sort of the technology on it. It wasn't quite there, so we had to go back to the drawing board. So we knew the problem. The problem was we wanted the customer to be able to have a vacuum cleaner do the job for them. But it has to be right. There's no point in putting something out there unless it does that job well. That's everything that Dyson's about. And by making sure that our focus was on the cleaning systems, we'd make sure we weren't ever going to make a compromise around that. Whereas if you start with a robot and you add the vacuum cleaner on second, you're always going to end up compromising your cleaning systems. And we weren't prepared to do that.
Now, because it's a vacuum cleaner first, and Dyson's really known for your motors, where exactly is the motor inside here?
Okay, so whereas on the other machine, you'll see a huge chunk at the back of the machine, which was a machine motor that we bought off the shelf, we decided very early on we needed to make our own bespoke Dyson digital motors. So in fact, this area here is the Dyson digital motor.
Now that's amazingly small for a motor.
I mean, there's an incredible team back at Malmesbury who spend all day, every day, really perfecting these motors, making them specific to each of our products.
And what was the biggest challenge in the last 18 years of your life putting this together? That's just such an amazing long time.
Well, the nice thing for me is I'm a roboticist, so for me it was about making the thing move. But we have many, many talented engineers, so we have a team working on the cyclones, making those perfect. We had the motors team, a pickup team, so there are lots of separate groups, each focusing on every aspect of the product and making sure they're as good as they can possibly be.
Now, this is really the first vacuum that you've released that had a camera built in. Did you have to kind of learn that technology as well?
Yeah, I mean, that was a huge step for us. And what we'd learned was we needed the machine to know where it was in the room. If you know where you are, you know where you've been, you know where's left to clean. And that's really critical because we put so much power and energy into our cleaning systems, we can't sort of waste time wandering around aimlessly. So actually we use the camera to tell the robot where it is. And then we have sensor technologies in behind the sort of black windows on the front here, which tell the robot what's in front of it. So if you imagine when the robot starts, it has a blank sheet of paper. As it's moving around, the camera's continually telling you, you're here, you're here, you're here, you're here. And then when he sees an object, it now can correctly put that on the map in the right location. So in fact, the camera is entirely around positioning the robot in the room, whereas the other sensors are around avoiding objects.
Now, of course, this is a Dyson vacuum, so we have to talk about the cyclone technology.
So the analogy I always use is my brother, who's a bit of a big bully, used to love, when I was on a roundabout, spinning me faster and faster and faster until eventually I was flung off. That's exactly what's going on in the cyclone. So small pieces of dirt, thanks to the incredible suction of the motor, is pulling the air round and round and round faster and faster, and eventually the dirt gets flung out sideways, it hits the edge of the bin, drops down, it's no longer in the airflow, and that's where it stays.
And Mike, what about filters? You know, a lot of vacuums have HEPA filters. Does this have one as well?
No, it doesn't have HEPA filtration, but what it does have is a pre-filter and a post-filter. They simply need to be taken out once a month, washed under cold water, put on a radiator, put it back in the machine, and you're good to go.
Well, Mike said it best, you know, there's a lot of technology, a lot of robotic technology inside this device, but it is still a vacuum first. So if you get it, you know it's going to work. So the big question is, Mike, what are you going to do for the next 18 years?
I think I shouldn't take 18 years for the next one, that's safe to say. So we're already working on generations 2 and 3. So what we're really committed to is robotics. The product being connected means that actually as we develop new software, we are going to be continually releasing new versions for this machine as well. So for instance, in Japan, where we launched in 2015, they've already seen 3 new versions of software just from an over-the-air upgrade. And we will continue that with this product. But everything about our future is built around vision. So again, Having a camera means you understand and can see the world around you. And what we're going to do is use more and more of that knowledge and embed that into the machine to provide better functions to the customer.
There you have it. If you're a neat freak like me and you love technology and you want to automate your life, you got to check it out. It's from Dyson. It's their 360i robot vacuum cleaner. Thanks, Mike.
No problem.